AI gives academic publishing an immense processing advantage, but carries a specific risk: the tendency to generate text that appears to hold unearned scientific authority. Large language models are probabilistic text engines. They do not calculate physical truth. Instead, they generate outputs that mimic the rigorous formatting of deterministic scientific proof. SecuredMe Scalarium is a pre-alpha educational research commons designed to bridge this gap between automated language and human verification. It operates under the Secured Educational License 2.0, legally codifying the boundaries for schools, researchers, and maintainers. The platform operates on the thesis that you cannot make a probabilistic model reliable through prompt engineering alone. While standard development tries to minimize these hallucinations, Scalarium uses hard architectural guardrails to subordinate the AI to human authority. It enforces this through three technical mechanisms: first, environment governance, then structural coaching, and lexical gates. Preserving scientific truth requires an environment where the system is structurally prevented from ever claiming physical validation in the first place. The foundational rule of the Scalarium environment dictates that official classroom routes strictly mandate the use of Codex/OpenAI or Antigravity/Gemini APIs. The system actively locks out unguided, uncensored local AI endpoints, such as Ollama Cloud. Educational safety relies on the governed provider-side refusal behaviors inherent to those permitted APIs. To enforce this safeguard, student and teacher sessions utilize browser WebAuth and strictly encrypted local session records. The architecture intentionally avoids requesting or storing raw local token files from users. OAuth callbacks are processed in transit, ensuring that access tokens are never retained as permanent profile data within Scalarium. This strict environment configuration removes the attack surface, preventing users from creating automated abuse workflows or bypassing established school controls. Securing the physical authentication environment is the mandatory prerequisite before a single line of scientific text can be analyzed. Once inside the environment, users draft their work with Quanthar, the platform's non-blocking formalization coach. Quanthar extracts a structural outline by parsing a raw text block into two parallel streams, one isolating structural formatting rules, the other isolating unverified content. It organizes Mizar-oriented plans on the formatting side, without altering the author's voice on the content side. This creates a strict epistemic rule. Quanthar's output is formatting assistance. It is never represented as clinical advice, biosafety approval, or verified scientific conclusion. Because it is a coach and not a gatekeeper, Quanthar operates on a non-blocking principle. The system will never prevent a user from publishing an imperfect or incomplete draft. If a user requires true formalization, the platform executes a mandatory handoff protocol. The drafted guide must be passed to a separate external formal verifier, like Mizar, to achieve actual mathematical proof status. By strictly separating the structural coach from the formal verifier, the architecture prevents the AI from assuming the role of an academic gatekeeper. This strict separation of language from proof is handled by Cynthia, using its core epistemic mechanism, the neutrino lexical gate. The gate's primary function is to intercept and classify simulation data before that data is allowed to reach the downstream FNP-QNN computing layer. The central node splits a data packet. Lexical metrics proceed left, while physical metrics are reflected back by a solid wall. The admitted node then filters the lexical data into distinct subcategories, separating terms describing flavor states from mass propagation states. When the simulation progresses to preparing an event container, Cynthia flags the output strictly as non-physical. This enforces a hard system rule. Executing an educational simulation does not equate to executing a real physical detection. Even when executing a complex passage comparison between two paths, the system prevents the output from being labeled a real CP measurement. Any metaphors or speculative language detected by the gate are partitioned and blocked from moving into the final data payload. By halting the AI logic at the boundary of language, the architecture enforces a structural separation. The simulation remains a research object, distinct from physical evidence. Cynthia extends these architectural boundaries to living biological taxonomies through its phase 1 through 7 biology layers. This requires plithogenic system math, a model where an abstract variable of indeterminacy is transformed by a living system context. This animation shows how nutrisophic probability values, true, indeterminate, and false, operate inside a pure abstract algebra engine. But those identical mathematical values carry a completely different meaning when applied to a real-world biological system. We see this in fields carrying real stakes, like food safety signals, or conservation concerns, and disease susceptibility reviews. Within a biological context, a high contradiction load is not an engine error to be smoothed over by an AI optimization routine. The architecture responds to this contradiction as a crucial system-level signal, one that intentionally breaks the automation loop. This break halts the process and triggers a mandatory human review by a qualified expert authority. Applying AI to high-stakes biology requires treating mathematical contradiction as a vital feature of nature to be reviewed, rather than a bug to be optimized away. These back-end mathematical boundaries dictate the entire front-end user privacy and publishing experience. The end result of the publishing pipeline is a research object that carries a time-stamped provenance receipt, explicitly avoiding any overreach into legal copyright claims. The document's context, including its attached Cynthia taxonomy annex, is preserved intact for community discovery. To ensure this material is accessible, the platform includes the Edge Access Console, a front-end tool designed specifically for neurodivergent focus and reading support. This schematic visualizes the console's strict privacy architecture. Interaction data loops entirely within a local browser environment, visually severed from external cloud analytics servers. Features like reading pacers, built-in sprint timers, and clean focus frames operate without storing a single point of behavioral data in the platform profile. This privacy by default design correlates directly back to the back-end lexical gate. Both systems actively refuse unnecessary data collection and computational overreach. The ultimate goal of Schoolarium is not to build an AI that can autonomously verify the universe, but to build an infrastructure that catalogs uncertainty and requires human authority for every final conclusion.